Hover Energy is a project that is not in our typical range of products we work on. However, it's very interesting from a lot of perspectives. It's an exciting renewable energy project, and we like being involved with that just because of the importance of it. Hover's doing something unique with respect to how they're harvesting wind and how they're integrating it onto microgrids, how they're exploiting the geometry of where they're going to put them. In other words, Hover is going to mount wind turbines. They are mounting wind turbines on top of buildings.
The Hover system is a microgrid that consists of a wind turbine and the ability to convert also solar energy into electrical energy to be hooked up to a building, power grid, or any other kind of grid actually.
And the way they're doing it exploits a very interesting aerodynamic property about how wind flows over the top of a building. So they get a little bit more efficiency out of their wind turbine than most in that class.
The project was initially just to help them build a prototype of a basic turbine design that they had started, and it's morphed into kind of optimization of the design and picking more efficient motors and things of that nature to try to make it a more efficient system.
We've been working with Hover Energy for about 2 years now. They came to us looking for a prototype. We helped get them their first prototype and into production now.
Initially, when we started the project, we started out with just doing a gap analysis of the current design that they have, and it has blossomed into a full project design and development phase.
The thing about Hover is it's a multidiscipline engineering project. There's control systems design, there's electrical and electronics design aspects, implementation challenges, but there's also mechanical and aerodynamics interaction there. So a wind turbine is converting wind energy into mechanical and then to electrical energy. So that whole process, they needed help with our systems engineering capability and our ability to implement control systems. Well, the Hover's problem was unique in that they had a concept and even a preliminary design, but it needed a multidisciplinary approach to make it a viable prototype and a production design. So we had to come in with mechanical folks, we had to come in with electrical design folks, we had to come in with industrial design folks, project management, software design, control systems design, because it just needed that kind of work across several different areas. Again, it's a complicated system that has all of those aspects that are needed. And so we brought the design team here that was unique, that was able to go address those needs quickly and get them into prototype and production.
Some of the challenges were just trying to find a motor that would work as a generator. In the wind generation industry, it's fairly small for what's out there. So trying to find a motor that would fit in this design, trying to find items that would last out in the weather for 25 years is of course a challenge.
The idea is to create energy from wind. It has blossomed into a microgrid, which means they want to be able to also include solar panels on it, and they also want to have any kind of energy that could be created, really.
I believe what's next for Hover is to get this product on the market and then continue developing and possibly develop a new version of the wind turbine that would have more power output and better efficiency, lower cost, things like that.
One of the reasons we partnered with Hover as opposed to just being a provider for them is because of where it's headed. Hover fills an important niche in the future of wind energy. They're an award-winning company. They've been recently awarded innovation awards from the investment community. There's several more coming because of where Hover is headed, because of the important needs they fill.
I'm originally from Western Washington, and I used to live in Idaho, and I drive through Eastern Washington all the time. And there's a point after the Columbia River Valley where it's just wind turbines as far as you can see. And they're wonderful, but they're expensive. The energy has to go very long distances to reach its customers. And these microgrids that like Hover is basically leading the way on allows small, medium-sized companies to access renewable energy a lot sooner than they'll be able to if they're waiting for that infrastructure to grow.
This innovation is incredibly world-changing. It is really well received by the industry.
Because they do wind energy in a class that is more accessible as opposed to the large mega windmills farms you see out there in the middle of nowhere. They're putting these things in an affordable size in a very economic space, and that's what's needed in wind energy. Well, in the case of Hover, it's because not only could we solve the problem, because we've got a really diverse and experienced team, but we were passionate about where they're headed. And so some of the projects we take on here are exceptional for what they can do to the world and do for the world. That's one of the reasons we exist here at Realtime, is to solve those kinds of problems. And Hover is one of those types of projects. And so we're pretty excited to be a part of it for that reason.
I think companies would partner with Realtime because we're very flexible. We can design from the ground up, maybe something's partially done, and take that from that point all the way to a product. We also have a very large talent pool of engineers and designers that are very creative and kind of cutting edge in the field. So,
Depth, experience, and the passion for the things we do. Our customers love the fact that we own their deadlines and their output as much as they do. We try to drive them to completion, and we have the experience to do that. In a lot of cases, because of the importance of the program, we become very passionate and invested in what they do, and so it's a pretty common occurrence here at Realtime.